In 17, we have a dodecagon where the area is 140 square inches, and that's all we know. It's also a regular. Doesn't say it here, but you have to assume it's a regular dodecagon. So what I wrote here on the right was the equation for the area of a regular dodecagon. So n's the number of sides, a is the height of this triangle, and s is the length of each side. So we have two unknowns, a and s, which means we need another equation here, and we could set up a system, because there's two unknowns. We can't solve for one specifically without having two equations. So I'm going to relate a and s. So this is a dodecagon. There's 12 triangles. So if we took 360 and divided it by 12, we get 30. So when you divide this dodecagon up into 12 triangles, each of these angles are 30 degrees. So then when this one triangle gets split in half, that angle right there is going to be 15 degrees. And this side is going to be s divided by 2. It's going to be half of that side length. So our other equation could just be tangent. The tangent of 15 degrees is equal to s over 2, opposite, over a. And now we have our second equation. So you could either type both of these into your TI-inspired CAS and solve, and you'll find an answer. Or you could do substitution. You could, express maybe a equals like s over 2 divided by the tangent of 15, and then substitute that into the other equation, or solve for a, however you want. This is probably better written like this: s over 2 times tangent 15, and then do substitution and solve that way. So that would also work. Okay, so now I typed those two equations in my calculator and hit enter. And make sure you're in degrees, because this angle represents 15 degrees. So I did it in radians at first by mistake, and I got false. So make sure your calculator is in the right mode. It should be in degrees. Then you get these weird answers. So if you want them as a decimal, you could just copy them. I'm going to hit Control Enter, and you see that the apothem is going to be around 6.6, or negative 6.6, but that wouldn't make sense. Alright, and if you don't have a TI-inspired CAS, you could just isolate one variable, plug it into the other equation, and then solve that way, and it just works out to be a quadratic. Remember, the tangent of 15 is just a number, so you can treat that as any other number when you're solving an equation.